time. From this point to the end of the semester, we'll be tearing down those land masses. We will be destroying those land masses via various means. So from this point on, it's basically erosion and modification of the landscape. One of the key terms that you will be exposed to, and don't be too surprised if you see it from time to time, on a couple of quizzes, not the one coming up, is the term differential weathering and erosion. And if you just simply look at the term, you have an idea of what it covers. What we're saying is different rock units will weather and erode at different rates. And because of this, it gives us the unique landscape appearances that we have. In your backyard here in Wausau, you have a landscape that was developed by differential weathering and erosion. And that's Rib Hill, or as the locals might like to call it, Rib Mountain. Rib Mountain is composed of a material called quartzite. Quartzite is a metamorphic rock that is extremely resistant to both weathering and erosion. Extremely resistant. One of the more resistant substances that we find naturally on your surface. It's composed of the mineral quartz. I believe there's a sign on Rib Mountain saying 99.some% SiO2, which is silicon dioxide, which is the mineral quartz. So here we have in Marathon County a landform that came about because of differential weathering and erosion. If we go back in geologic history, here's a quartzite feature. And this is literally covered by granite. Literally, the quartzite has been intruded into the granite mass. Of these two rock units, the granite is softer, breaks down relatively easily when compared to the quartzite. And so over a period of time, what has happened is literally this granite has eroded away, and in time, what we're looking at is something like this. Granite is still at the base, and the quartzite is still standing well above the landscape. And the reason for this is, again, differential weathering and erosion. These two units are weathering and eroding at different rates. And what will happen in time is the difference between the high point and the surrounding surface becomes greater as the granite continues to erode at a faster rate. In time, we may actually have Rib Mountain here in Marathon County. Right now it's a hill. The distinction is, to be a mountain, you must have relief, which is the difference between the high and low point of 1,000 feet. And I think currently it's 800 feet from the summit to the base. But over time, this is going to erode faster, and so the relief increases over time. So in time, you may have Rib Mountain. The tourist industry obviously is optimistic, and so they named it Rib Mountain a century ago, but it really isn't a mountain. Okay, I've used the term weathering and erosion. They are somewhat related, but they're two different processes. When we did the rock cycle, we mentioned the word weathering. And weathering, quite simply put, is the decomposition or disintegration of large rock units into smaller units. Decomposition or disintegration of large rock units into smaller units. We talked about this when we talked about soils. And when bedrock is broken up, it produces what? When bedrock is broken up, it produces what? Regolith. Regolith is broken up, it produces sediments. So all of this is a weathering process. So you're taking large rocks and producing smaller specimens. There are two types of weathering, two major categories. Physical weathering, and in one of the two textbooks, the term mechanical is used in place of physical. So in some of the textbooks, the term mechanical weathering instead of physical. They're one and the same, just people opt for different names. Physical weathering is simply a reduction in size of a particle. That's all it is. If I happen to have a plate and I dropped it on the floor, you'd end up with pieces of a plate, but every segment would be much like the original, except you only have a small size. No other changes have taken place. All you've done is reduce the size of the mass. There's one other thing that happens. If we take a large substance and we break it down into smaller units, there's one other thing that we've accomplished, and that is we have increased the surface area. By breaking something down, you increase the surface area. If we were to take that big piece and just break it in half, we have introduced two other surfaces to weathering. The two that would be along the fracture line. Physical weathering facilitates chemical weathering. Physical weathering facilitates the chemical weathering process. Without physical weathering, chemical weathering would be significantly slower. So without physical weathering, chemical weathering would be significantly slower. For instance, how many coffee drinkers do we have here? Great. How many coffee drinkers use sugar? Okay. How many of you use a chunk of sugar as opposed to granular packets? If you use the cube of sugar and you throw it in a container of hot coffee, and in an adjacent container you take the equivalent amount of granular sugar and you start stirring them up, which one will dissolve first? The granular, because you have more surface area. Same thing happens in the natural environment. The more surface area you have, the greater the amount of chemical weathering that will occur. So physical weathering literally aids in the chemical weathering process. Now, you don't have to give away any family secrets, but do we have any beer drinkers in here? Okay, I kind of suspected we get one. In a hot summer day, you bring this case of beer home. It's in bottles, but you need a cold one in a hurry, so you throw it in the freezer. You get busy with something else. What's going to happen? So what? It's going to fracture the bottle. Why? What expands? Oh yeah, the beer is going to expand. Now, if you look at the entire picture of what we have on the earth, when things are exposed to cold temps, do they expand or do they contract? When things are exposed to cold temperatures, they normally